cosine, and tangent to find missing sides and missing angles, right? And you guys already knew how to do that from geometry, but we were just reviewing how to use those ratios, opposite over hypotenuse or adjacent over hypotenuse to solve for those missing sides or missing angles. The reason that we needed to review that is because of what we are going to be talking about today. We are going to be putting those right triangles on a coordinate plane, which eventually leads into our unit circle. So that's why I wanted you guys to already have your unit circle memorized, because we're going to be adding things to it. So if you already know the degrees and radians, then you're set. It says here that the radius vector r. Well, radius, remember, is just the distance from the center of the circle to the edge, right? So if you were to have a circle on this coordinate plane like this, okay, my radius, oops, that's not very centered, that's okay, is from the center to the edge, right? My radius isn't negative even if I have it going this direction, right? My radius is just distance. So whenever we're talking about there being a vector for the radius, your radius is never negative. Okay, whatever value r is, it's always a positive number because you're just measuring distance, not necessarily the direction there. For the distance from the origin, and it is going to be the terminal side of theta. Remember, theta is just whatever your angle is, right? Usually measured in degrees, but also sometimes radians, so we have to know how to measure both. It says since r represents a distance, it's always positive. All right, so whatever r is, always a positive number. Now, if I were to have a right triangle on the coordinate plane and that the r vector that they drew here was the terminal side of the angle, then this is my theta, right? So I could draw a line here, and then I already have this line down here, and now I have a right triangle that I made with that vector, right? Where theta is the angle. Okay, well, this bottom side right here of my triangle is just the distance that I traveled on the x-axis, right? However many units over. So this is some x value. And this side over here is where I traveled so many units up, right? So this would be some y value. So previously, we always referred to our opposite and adjacent sides as O and A, or opposite and adjacent. Now we're going to be referring to them as X and Y, because if they're on a coordinate plane, one of them is an X value, one of them is a Y value. Now, my theta should always be here towards the origin. And if that's the case, which one is opposite of theta, Y or X? Y. So y is always going to be the opposite side, no matter which direction I draw it. And x is always going to be right there beside theta, right? So x is always going to be my adjacent side, no matter which direction I draw it. So anytime we're talking about our right triangle on a coordinate plane, instead of giving opposite over hypotenuse, we are going to write the ratio as y over r. Because y is the opposite sign, while r is where our hypotenuse should be, right? And instead of using adjacent over hypotenuse, we're going to use x over r. And instead of opposite over adjacent, we're going to use y over x. We are able to do this because these are going to be similar triangles that we're drawing around here, no matter the direction. The numbers can change, but the look of the triangle is going to stay the same. It says this satisfies the requirement of a function such that each x value, or in this case theta is our center point there is only one y value. So remember, for something to be a function, x values cannot repeat, right? Okay, so like we said, sine used to be opposite over hypotenuse. Now it's y over r, because y is opposite and r is the hypotenuse. Okay, and then remember, cosecant is its reciprocal, so it's going to be r over y. We flip it over. Cosine used to be adjacent over hypotenuse is now x over r, because x is the adjacent side and r is the hypotenuse. And remember, secant is its reciprocal, so it's r over x. And the same is true about tangent and cotangent. Tangent's y over x, so cotangent is x over y. All right, so still the same ratios, we're just using different letters in those places. All right? Okay, so flip it over on the back. It says here, if the terminal side of theta in standard position passes through the point P, draw theta and find the exact value of the 6 trig functions of theta. So really, when they say to find their value, all they want us to do is write these 6 ratios. Just tell us what the fractions would be. We're not actually putting anything in our calculator right now, all right? So on number 1, our point P that they said the terminal side goes through is at 6/8. So I'm going to go to the right 6 units. So maybe that would be somewhere in here. And I'm going to go up 8 units. So maybe that's somewhere up here. And they said that's going to be the point that my terminal side of my angle goes through. So this is where our vector R goes through. And remember, we said theta is this angle right here, right towards the origin. Okay, and we know that this is the x value down here at the bottom. Well, what was the x value of this coordinate point? 6. So this side has a measure of 6. And we know the opposite side is a y value, right? And what was the y value they gave us? 8. So this side must be 8. Okay. So we know 2 of the 3 sides. How could we maybe find R? Right, Pythagorean theorem. So I'd have 6 squared plus 8 squared equals that hypotenuse, which we're calling R squared. All right, so what is 6 squared? 36. And 8 squared? Good. Equals R squared. And what is 36 plus 64? 100. So 100 equals R squared. But I just want R. So what do I need to do? Take the square root. And what is the square root of 100? 10. So R must be 10. Okay, this one is also a multiple of our triple. 3, 4, 5. This is 3 times 2. This is 4 times 2, and this is 5 times 2. So if you have your triples memorized, you don't have to do this work over here if you already know. All right? Okay, now we just need to give the ratios. So we're going to start with sine. Sine, we used to call it opposite over hypotenuse, but now we know it's y over r in this picture, right? Okay, so here's my y, and there's my r, so my ratio is what? 8 over 10. And that would simplify to what? 4/5. Good. Okay. All right, then we're going to look for our cosine of theta. Remember, cosine used to be called adjacent over hypotenuse, but according to the front page, it's now x over r. So what's x over r for us? 6 over 10, which simplifies to? Good. All right, and then we need tangent. Tangent used to be opposite over adjacent, which is now y over x. So that's going to be 8 over 6, which simplifies to 4/3. All right. Okay, so there's the first 3. Now we need their reciprocals. So we're going to start with sine. Its reciprocal is cosecant. So cosecant would be what? 5 over 4. Oh, I thought you said 5 over 6. I'm sorry. Okay, and then for cosine, our reciprocal is secant, which would be 5/3. Okay, and then tangent's reciprocal is cotangent, which would be good. And that's it. That's all we have to do. All right. I want you guys to try example number 2. So draw your triangle. using that coordinate point that they gave you. And then you're going to find the missing side and write out your ratios. So I'll give you a second to do that, and then we'll share our answers. All right, looks like we were all able to draw that triangle and find the missing side. So let's talk about what that looks like. So we knew that the terminal side went through the point -4, +2. So -4, +2 probably hits somewhere in here. So my terminal side had to go through that point. So it looks something like this. And theta was down here. And they told us the x value was -4 and the y value was 2. So we were looking for r, right? Okay, and what did we do to find r? Pythagorean theorem, right. So I'm going to have 2 squared plus -4 squared equals r squared, right? And 2 squared was 4, and -4 squared is 16. All right, and 4 plus 16 is 20. So we had to take the square root, right? There is no perfect square root of 20, but we do have to keep it exact. So I don't want a decimal there, right? What I do want to consider is if I could simplify the square root any. Because 20 is a decent sized number. Maybe there's something that I could take out of 20, right? So let's think. Is there anything that multiplies to give us 20 that does have a square root? 4, right? 4 times 5. What is the square root of 4? 2. Okay, so I could take out a 2, but the 5 doesn't have a square root, right? So it stays behind. So this would be equivalent to 2 square root of 5. So that's what I'm going to use for r. All right? So we're starting with sine. Sine, remember, is y over r. So what's y over r for us?
2 over 2 square root of 5.
Good. 2 over 2 square root of 5. Okay. But we don't leave a radical in the bottom of a fraction, right? So how do I fix that? Multiply by root 5. Okay, so I multiply the top and the bottom by root 5. So in the numerator, that's going to give us 2 root 5, right? And in the bottom, that's going to give us what? a 2 here, and then what's root 5 times root 5? 5. So 2 times 5, 10 in the bottom. Okay, so we have 2 root 5 over 10. Can I simplify the 2 and the 10? Yeah, right? This would just become 1, and this would become 5. So we're left with root 5 over 5, right? Okay. All right, now let's look at cosine. So cosine is x over r, right? So what's that look like for us? What's cosine?
X over
Mm-hmm. So what numbers is that for us?
2.
Good. And same thing, right? We can't leave the square root in the bottom, so I'm going to rationalize. I'm going to multiply by root 5, which gives us negative 4 root 5 over 10 again, right? Can I simplify that negative 4 and 10? Yeah, by what number? 2. So this is going to become a 2, and this is going to become a 5. So this would be negative 2 root 5 over 5. All right, and then we need tangent. What's going to be my ratio for tangent? Which is y over x now, right? Since we're using y and x, so what are those numbers? All right, and what will 2 over negative 4 simplify to? Nice. Okay. So there's my first 3. Now I need their reciprocals, right? So we're going to start with cosecant, which is the reciprocal of sine. So remember, that's going to be r over y, right? So what is that? And those 2's will divide out, right? So I'm just left with root 5. Okay? Now we're going to look at secant. Okay, so the reciprocal of cosine. So this one should be r over x. What numbers is that?
5
Good. And that 2 and negative 4 will simplify, right? So we're left with negative root 5 over 2. All right, and then lastly, we've got cotangent. So this is the reciprocal of tangent, so it's going to be x over y, which would be
negative 4 over 2.
very good, which simplifies to
Negative 2.
nice. All right. So still doing the same type of thing, we just put it on a coordinate plane, all right? Okay, one last thing we need to talk about. It says we are going to determine which functions are positive in each quadrant. So we're going to do that before we answer questions 3, 4, and 5. All right, so if I were to draw my right triangle here in quadrant 1. Oops. So I've got my radius, my x, my y. In quadrant 1, are x and y positive? Yes, okay. And r is always positive, right? So if I have a ratio that has any of those involved, they're all going to be positive. So in quadrant 1, looks like everything is positive, right? So here, they are all positive. Okay, let's look in quadrant 2. So in quadrant 2, we've got a right triangle here. Oops. Why is it doing that? Okay, where in quadrant 2, we know that x is what? It doesn't like this one. It's negative, right? So here, any of my ratios that involve an x in them are going to have a negative x, but a positive y, right? So here, negative x, positive y. Okay, so let's think about it. Which ratios involve x? Sine, cosine, tangent? Cosine and tangent. Okay, so there, cosine and tangent are going to have a negative x, so they're going to end up being negative, right? So which one is the only one that's going to be positive then? No, which ratio is the only one that's going to be positive then? Sine, right. That's the only one that doesn't involve x, right. Okay, so here, sine is going to be positive, okay? In quadrant 3, if I were to draw my right triangle, like we already said, x is negative over here. What about y in quadrant 3?
Negative.
Also negative. But r is always positive. So we're going to have a negative x and we're going to have a negative y. Okay? So now sine is going to have a negative y and a positive r. So it's now negative, right? Cosine is going to have a negative x and a positive r. So now it's negative. And then my tangent is going to have a negative y and a negative x. Well, two negatives make a what? Positive. So which one's positive in this quadrant? Tangent. Because it's going to have two negatives, which make a positive. All right, and then we've got quadrant 4. So here's my right triangle in quadrant 4. Okay, here is x positive. Yes. Is y positive? No. Okay, and r goes here. All right, so now we know anything that involves y is now negative. So which ratio does not involve y? So in this quadrant, we know that cosine is going to be the only one that can be positive, right? Okay, we have an acronym to help us remember which ones are positive where, okay? It goes counterclockwise just like our quadrants do. You know, this is quadrant 1, quadrant 2, quadrant 3, and quadrant 4, right? Okay, here, A. A is going to be for all. S for sine is going to be students. T for tangent is going to be take. And C for cosine is going to be classes. So our acronym is all students take classes, to help us remember which one's positive where. And it starts in quadrant 1 and goes to quadrant 4. All right? So all in quadrant 1, sine in quadrant 2, tangent in quadrant 3, cosine in quadrant 4. Okay, so now that we know this information, let's answer questions 3, 4, 5. Number 3 says, cosine and tangent have the same sign. So, same sign means they're either both positive or both negative, right? Okay, so in quadrant 1, are cosine and tangent going to be the same signs? Yeah, because everything's positive there. Okay, so quadrant 1. In quadrant 2, are cosine and tangent going to be the same signs? Yeah, they're both going to be negatives there, right? What about in quadrant 3? No, because tangent's positive there, right? What about in quadrant 4? No, because cosine's positive there. So only in quadrants 1 and 2 will they be the same, both positive or both negative. Okay, number 4 says cosine is negative, okay? Well, cosine is negative in which two quadrants? Cosine is negative in which two quadrants? Second and third. And sine is positive. Where is sine positive? The first and second. So the only overlap there is in quadrant 2. So that would be true in quadrant 2. All right, lastly, we've got cotangent and secant. Well, those are the same as as tangent and cosine, right? They're just the reciprocals, so their signs should hold true. So if tangent's positive here, then so is cotangent. And if cosine is positive here, then so is secant, because all I'm doing is flipping them over, right? I don't change signs. So I want to know where those two would have opposite signs. So where one of them's positive and the other one's negative, where would that be true? 3. In 3, cotangent will be positive and secant will be negative. And where else? 4. Because in 4, the opposite's true, right? Secant will be positive while cotangent will be negative. All right.